Hello, gentlemen. Welcome back. Hopefully everybody understands partial fractions, has a good idea on how to handle those situations, even with the repeated linear factors and the quadratic factors. It was a little bit more demanding, but hopefully you guys get the process and can go through that without much difficulty at this point. The purpose of this video is to look at inequalities. We're going to look at systems of inequalities and looking at graphical representations of the solutions. So let's get started. We'll do a couple examples in this video, and then I'll do a second video with a little bit more complicated stuff and some word problems. First one is sketch the graph of the inequality 5x plus 3y is greater than negative 15. Hopefully you look at that and you understand that that's a linear equation, basically, linear inequality. First step that I want to do here is sketch the graph of 5x plus 3y equals negative 15. This is just the equation of a line. And so what I can do is I can certainly put that into y is equal to mx plus b here. If I do that, I get the equation here. Let's just write that out. I would get y is equal to negative 5/3 x minus 15, like that. Okay. So first thing is to graph that line. There it is. The next is whether or not I put a dotted line or I put a solid line. Because it is just greater than, I'm going to put a dotted line. A solid line means greater than or equal to. It means that points on this line are not in our solution. Okay? Because obviously, if a point on this line, is going to be an equal, it's going to satisfy this equation right there. But I don't want equal to 15. Equal to 15 does not satisfy this inequality. Okay? So the dashed line means that it's not part of the solution. Once I get the graph drawn, what I want to do is I want to test the point. I want to decide which side of this do I shade. Do I want to shade above this curve or below this curve? So I need to pick a point. The easiest point here to pick is 0, 0. Okay. If I plug in 0, 0, I'm going to get 0 on this side. Is 0 greater than negative 15? It is, so I should be shading above. I only need to do one test point. Okay. So we should see that we're going to shade above that curve, like that. Okay, so all points above this line are going to satisfy this inequality. All right, that's a pretty straightforward one. Let's look at this. Hopefully you guys going way back remember that this here is the equation of a circle. Okay, you should know that the center of the circle is at the point 1, 4, and the radius of the circle is equal to 3. Big a blast from the past right there. Okay, so there's the graph of my circle. All right, now I want to find out, again, I need a test point to determine whether I'm going to shade in or out of the circle, either inside or outside. Also note that I have a solid line representing my circle, and the reason I have a solid line is because I have the greater than or equal to. Okay, and that means that points on the circle satisfy this equation, which it should because we have the equal sign there. So let's pick a test point. I would pick the point, simple point here would be 0, 4. 0, 4 is inside my circle, so let's see if I want to shade inside or outside of the circle. If I plug in a point, I'm going to plug in, if I plug in that point, I get negative 1 squared plus 0. That equals 1. Is that greater than or equal to 9? No, it isn't. So what I should note is I want to shade outside of my circle. Okay? Like that. Alright? So all points outside on the circle and outside of it are going to satisfy this inequality. Alright? Well, let's do a system of equations here. This is a little bit more. I want to satisfy both of these conditions here. Okay? That's the key to understanding this. I want to solve both of them. So let's start with the first one. Okay, let's start with the top one. X minus 2y is greater than or equal to negative 6, so I want to graph that line. There it is. Okay, and again, I want to be greater than that, not greater than or equal to, just greater than, so I need to test the point. All right, again, the easiest point to test here is 0, 0. If I test 0, 0, you guys should see that 0 is greater than negative 6, so I want to shade underneath. Okay, like that. So solution to this first one is all these points down here. Okay? Now what I need to do is look at this other one. So let's look at that. All right. So let's graph that line. There it is. Okay. And again, I want to test points. Are we above this curve or are we below this curve? All right. And so if I plug in, again, 0, 0 is a good one. It's on this side of the curve. If I plug in 0, 0, I'm going to get 0 is less than -9. That's not true. So I want to shade above the red curve, above this curve right there. Okay, like that. And now what I want to do is I want to combine those two that I just did. So I want to combine these two. I want to be below the blue line and above the red line. Okay, I want to put them on the same graph, so let's do that, below the blue and above the red. So I want to be below, I want to find the points that satisfy both of those conditions, where I'm below the blue line, down here, and above the red. And what you should see is that the solution is going to be right there. Okay, those are the points that are below the blue line and above the red line. Okay? Hopefully that makes some sense. Here's some reading and some practice problems. Again, you should have done a little bit of this in Algebra 2. It's not overly complicated. You got to break it down. The next video will do a little bit more complicated ones, but the idea and the principle is the same. First, you want to graph the curve, and then you want to test points either inside the circle, outside the circle, above the line, below the line, inside the parabola, outside the parabola, depending upon what the graph is. Okay, and then once you have your test points, you're going to know where to shade. And then when you have systems, you have to combine those. All right, so hopefully that makes sense to you. If you have any other questions, please make sure you go into Google Hangouts or you email me. All right, fellas, have a good day.